there are three variables in this experiment that are independent, dependent, and controlled. So this one is independent variables. We take reading the flow rate from the rotameter. And second, dependent variables are pressure difference from venturi, orifice, and 90 elbow. For the independent variables we can take reading from the flow meter and time taken and the time taken for 10 liter reading. And lastly, for the control variables we take 10 liter reading.
So for our M1 experiment, we will have a manometer tube, a venturi, orifice, a rotameter, a pump down there, and then a stopper, and then the last one is a timer.
Okay. Turn on this power supply and the switch on. Then we open the control valve and the discharge valve. Make sure there's no trap bubble in the pipes. We then, with the amount your group has set for the rotameter, we put it at the amount you set, and then we measure the flow meter. After that, we close the hole with the stopper, and then take time until it reaches 11 liter. It starts from 1, so it's only 10 liter. That's all.
For the expected result of this experiment for the flow meter measurement apparatus, the first one is regarding the general behavior of the fluid. Our data confirms that it is a Bernoulli principle. The cross-sectional area of the pipe, when it decreases, the velocity of the fluid will be increased, so causing the static pressure for head to drop. We also found that the flow rate is directly proportional to the variation of head across the device. Basically, as the head value rises, the flow rate rises with it. Next, moving on to the venturimeter. For this venturimeter, the device demonstrates the highest performance, the head loss. Because of the streamlined shape, it is gradually narrowing and then expanding. The venturimeter showed the lowest pressure drop, energy loss among the device. Next, the discharge coefficient. In this venturimeter, it yields a high coefficient of discharge ranging close to 1. And the accuracy, consequently, the venturimeter was the most accurate device, with an average percentage error of only 0.9% compared to the actual flow rate. Next, the orifice meter. For the orifice meter, the head loss. Due to the sudden contraction of the area, the orifice plate caused a severe drop in pressure. The drop is largely unrecovered. It has a discharge coefficient, and the accuracy of the orifice is expected from this result. The rotameter, the devices from the float devices from the rotameter, it used to determine flow rate. While reliable, we noted that rotameter is susceptible to human error, specifically parallax error when visually reading the float's position against the scale. And lastly, the 90-degree elbow. The sharp change in direction disturbed the smooth flow, causing turbulence and separation, which result in minor head losses. I think that's all for me.
For the safety awareness of this experiment, we need to make sure the switch is off after use, and also the water is drained inside the apparatus after use. Next, we also need to wear a suitable attire, which is both clothes and shoes. We also need to make sure the apparatus don't have any blockage, and the last one, we also need to make sure the apparatus is not exposed to any stresses and shock. That is all for safety awareness. Thank you.